We would now like to introduce you to the flagship in our range, the 911 Thermoforming Centre. This dedicated educational machine will carry out 6 different thermoforming processes, all in one composite and mobile unit. On the right-hand side here, we have the injection moulding extrusion rig with a high thermal mass pot already in position. Into this pot we load the material, which is first of all heated in the oven, which forms the centre of the machine. The oven is temperature controlled with a digital readout temperature controller, and the heater system of the oven doubles for the vacuum forming, which is in the far left side of the machine. At the moment, the vacuum forming aperture has got the dome blowing rig assembled, and it will also take a plastic coating fluidized bath in that same aperture. On the very far left of the machine, we have a folding work table, which also houses the plastic welding torch, which is also controlled from the central panel of the machine. We will now introduce you, first of all, to the dome blowing rig on the left-hand side. We have already set the toggle clamps here so that we get the correct amount of clamping force once we have a piece of 3mm 1/8 inch acrylic sheet under this ring. This is the material that we will be using. It is cast acrylic and the protective covering has already been removed. We are going to place this in the oven, for which protective gloves should be worn. The oven has already reached its 160 degrees Celsius, so we can load it in on the shelf and close the oven up. It will take about 8 minutes to heat through. The cast acrylic has now been in the oven for about 8 minutes, and we'll just prepare ourselves before we actually remove it from the oven for blowing the dome. We lift the ring up, we're ready to accept the material, and we check that the switch is in a convenient position adjacent to the dome blowing controls. We wear heat protective gloves because the oven has been running at 160 degrees Celsius, and we offload the material, and you can see that it is now completely rubber-like. You have about a minute to carry out this operation. Clamp the material firmly down and select the dome blowing blow control. When the dome is high enough, switch to hold. The dome is now cooled and is quite rigid. We can turn the pressure pump off and remove the finished dome from the rig. There you hear the small amount of air pressure being released. It's less than 1 bar, approximately 10 pounds per square inch. And carefully lift the ring clear and remove the dome. There you have the finished blown acrylic dome. We will now convert this left-hand station for vacuum forming. We lower the platen so that we can remove the dome blowing rig, and we replace it with one of the 2 vacuum forming plates or masks which are supplied with the machine. This particular one is for a 12-inch square or 300mm square sheet. The other one is half of that size. The mould that we're going to use is a face mask, which is made out of epoxy resin and mounted on a baseboard. We load this into the vacuum forming aperture of the machine. We can have a practice run whereby we will bring this aperture up to actually do the forming process. Get the feel of the mechanism and load on a sheet, which in this case is a polystyrene material about 1.5mm or 60,000ths of an inch thick. Bring down the clamping frame to create a seal around the silicone foam seal which is below. We move the heater now to start the heating process. By watching the material under the heater, you can judge once it has sagged about 25 millimeters or 1 inch, the material is soft enough to vacuum form. We can switch on the vacuum, remove the heater, and bring the mould up into the forming position. Forming takes place almost instantly. After a few seconds, the material will chill on the mould, and we can revert to the blow mode on the central switch, and reverse flow air will apply even pressure on the forming to release it from the mould. Switch off and unload the finished product. And now onto the subject of moulds. In this vacuum forming demonstration we used a resin cast mould of a face mask. However, educationally, most moulds will start life made of wood, and they needn't be particularly complex. This simple wooden mould can be made with all the basic woodworking equipment, and in fact produces a switch cover which we use on one of our vacuum forming machines. Similarly, this very simple mould will make a plenum box for one of our dip coating tanks. Imagine fabricating that in steel. Moulds can then become a little more sophisticated, and here is a simple mould of a telephone where you can see that we have used punch press blanks for some of the keypads. Again, the rest of the mould is fairly simple, straightforward woodwork. I'm now going to take the switch from the vacuum forming mode over to the oven mode, which brings the temperature controller into play once more. And we need a much higher temperature than for dome blowing, so I will now reprogram the controller to 260 degrees. The item we've chosen for plastic coat is a metal handle, metallic handle, onto which we have attached a wire retainer so that we can hold it to dip into the tank. We'll load this in the oven at the new set temperature to preheat. Whilst that is heating, we can convert the left-hand station for plastic coating. So we remove our vacuum forming mould, we lower the platen, and this is our powder in the tank here, which we've just filled up, and as you can see it is a very fine nylon powder, in this instance coloured red. We can now load the tank into the 12-inch vacuum forming aperture and clamp it in position with the clamp frame. By operating the central control here to the appropriate station, we are then going to be able to fluidize the powder in that tank to allow us to dip the material when it's attained its heated temperature. Screwing down of the adjuster allows you to control the level of fluidization, and you can now see that the powder is becoming fluid, and a simple test is to test the fluidity with a cold implement just to see that it easily dips in the powder. The component has now been in the oven for about 12 minutes, so we can remove it and immerse it into the powder. Move it around a little and 3 or 4 seconds, shake the excess off, and then wait for the heat to penetrate the outer particles of powder to give us a nice, smooth plastic coat. And now for injection moulding. First of all, we reset the temperature controller to 190 degrees Celsius and allow the oven to stabilise. We prepare the oven by turning over the shelf. Where it will be found there is a bracket to support the material pot. We now allow the oven to stabilise, and whilst we're doing that, we can prepare the material pot, which is this component here. We are going to use polyethylene powder, in this case a blue, and fill it as full as possible. Using the handle provided, we can put this into the oven. Into the holder provided on the shelf. 2 moulds are provided with each machine. A simple component box and a small wheel. For this exercise we will use the wheel and prepare it by simply screwing the 2 halves of the mould together with the 4 set pins. When we put the material pot into the oven, we set the timer to 20 minutes, which is the time needed for the material to thoroughly absorb the heat of the oven. That 20 minutes is now up, and we then take the selected mould and put it in the oven for a further 3 minutes for a preheat period. So we can again use the timer, reset it to 3 minutes and start the timer running. The timer has now timed out, so in preparation for the actual injection moulding, we can switch to the appropriate station on the front control panel. We then open the door of the injection moulding rig and remove, first of all, the mould itself and put it into position. We then take out the material pot with the holder, where you can see that the material is molten down into a fluid state, and load it in like so. Close the door with the safety interlock and operate the ram to complete the process. The ram will continue to move for several seconds as it fills the mould. The mould is now cooled, and we are removing the last of the 4 clamping screws, and then we wind in the extraction screws which force the 2 parts of the mould apart. We then remove the top part of the mould and the finish forming like so. Having successfully completed the injection moulding, we now move on to extrusion, which starts off in a very similar way. We have a material pot, but the end of that pot has a spark eroded die through which the material will be extruded. This is loaded in exactly the same way, but this time using polystyrene granules, and put into the oven to preheat for 20 minutes. For the extrusion process, we have loaded in the water tube, which will provide buoyancy for the extrudate as it comes out of the nozzle. The timer has now indicated that the 20-minute warm-up time is complete, and we're ready to remove the heated material pot from the oven. We load it into the injection moulding extrusion rig, close the safety interlock door and bring down the plunger. The extrudate will now appear out of the nozzle of the rig into the water tube. We are now going to demonstrate the welding equipment for plastic welding using two pieces of polypropylene. We've now switched on the welding torch with the appropriate control, and we've got it set up with the shafting tube in position, picking up heated air from the barrel of the torch. And we will now touch these two pieces together intermittently along their length. So we've now completed the tucking procedure and we now actually do the weld. We place the welding rod down this guide tube on the top of the nozzle. As it passes through, it will become heated, and the little shoe on the end here will firmly push the heated material into the V-joint. We'll feed the rod into the preheat tube, pause a few seconds while it warms up, and start the actual welding bead, pressing on the rod as we proceed. Once underway, the rod will self-feed, and you control the speed of welding so that the rod just flows through. Cut off the rod and remove it from the tube like so.